Well, audit logging and compute. I don't like the word maintenance. It's really bookkeeping, but ruins the alliteration. So we'll try again. The first problem to solve in auditing was what are we trying to solve? As in getting events for the administrator. The verify later, and what events do we care about? We care about things like when a task is received on the endpoint, when a task is sent to the executor, when a task is actually running, if the executor provides that, and then when the task finishes. That's the problem on the outset to attempt to solve. Um, at least from the tickets go. There's more could be done here, but that's what we decided upon when we started to do this. So the question is how to pull that out from Parcel, which does a fraction of this already with their monitoring. And a reminder then, first of all, is that we are built upon abstractions in our field. And in Parcel, we're no different. We've got the worker, which is the actual task processing. We've got the manager, which talks to the workers and passes tasks and results back and forth, which talks to the interchange, which talks to the executor, but the executor also starts the manager, and these are all different abstractions for different details within the computing aspect. And we have the provider, which talks to the scheduler and the scheduler itself. I'm confused again, as usual. And the Globus compute side is no different. We have our SDK task concept, which we pass to the web service, which carries a different aspect of the task concept, which eventually passes it to the endpoint, which is where the admin starts to care about when the task comes in and the executor task. So we're kind of working in this talk in that layer between the executors. On the executor, parcel executor, and our endpoint executor, which is the parcel executor side of things. So reminder then, the compute tasks, who cares about what? Pardon this audience, I was thinking a different audience, but here we are. So I will jump through these. What we care about is where the admin wants to know information. A reminder, we'll look at the endpoint and the executor side of things. All right, so nominally we have the web service ID, as in we're tracking this task that the user wants and the admin needs to, or the endpoint needs to get through. So this is nominally a simple task. We receive a task, we finish the task, put it in the log, and move on. We already get the ID, move on. But as always, there's a couple of complications. We'll remind here of the part two of the problem is not just that we have a task we start and receive, but where it exists. As in, Parcel has a notion of the blocker in his logs, and we have the scheduler's job ID, and which allocation it gets is important, especially from an administrator's perspective or debugging a problem later on. Okay, bookkeeping, here we come. So back to the simple task, we've got the Parcel saying, no, we're going to run this task again as an example. So this task failed for some reason, maybe not part of the task problem, or maybe part of the task problem, we don't know, but we're going to rerun it. But in rerunning it, Parcel gets a new executor ID, and we still have our original task ID. How do we make the two meet? We got to be aware of when Parcel changes it. Holding on to that for later. And same idea, the scheduler thinks in jobs, not tasks. So we've got to make sure we keep that updated as well if that changes, because Parcel can move tasks around between jobs as necessary. Moving on, that's not even our biggest detail. Our biggest detail is that we don't use Parcel's data flow kernel. We directly instantiate the high throughput executor, which means that we don't even start a configuration for monitoring. So the black magic we do is we dig into Parcel and say, what does Parcel do? Parcel relies on the existence of the monitoring messages variable. And so that bold part there in the comment pulled from is, that's the whole thing. Magically set this variable, and now Parcel will write to this queue. It is what it is. We can have a better approach to it at some point in the future when Parcel and we agree on a better interaction. But for now, this is the black magic we do. We set this. And we'll get back to that in a minute. So hold on to that mention that the idea that monitoring messages is the queue that receives information about where tasks are. So begin bookkeeping on the Parcel side. A reminder again of who talks to what and where we care about. The HTEX starts the interchange, and then turns around once the interchange is started and starts managers as appropriate for tasks. And Yadu, you will correct my precision on statements, please, as I move forward here. then gives the address of the interchange to those managers and is mostly hands-off at this point. The communication happens between the node managers and the interchange. And so the reminder then of a node manager, that is simply a process on an allocated node. So if you allocate 10 nodes, you normally have 10 node managers. And these node managers turn around in turn and start the actual worker processes, give or take child processes. And in a naive case, a reminder, this is a worker might be one worker per core, but that is meh. We don't care about that because we care about is who talks to who, and the layer we care about is between the interchange talking to the managers, because the interchange holds the data, what we care about of where the tasks are. Because once you're on a node manager, you're on an allocation or a job, you're on a block ID within parcel, we care about that center bit, which I bolded the wrong thing here. The interchange talks to the managers and getting the information out of the interchange back to where we are. So reminder of the bookkeeping to hold on to. Now, this is the first fun one in my brain. When I first started this task, I was thinking, okay, I want to get where the tasks are. So I'm going to go to Parcel and have Parcel tell me, okay, a task is assigned to job ID 1 on block 7. And great. Well, no, that's not how Parcel does the task sharing. It does it more intelligently, more bulky by sending the task information as associated with the node managers. So when a node gets more tasks, then it submits what tasks are assigned to that node as a node info block, as opposed to individual messages for each task sent. And actually, that's a more efficient way of doing it in bulk think in general. So good on Parcel, bad on me, my initial thought process. And then I'll show where this is the case here, but how are the tasks identified within Parcel? They're identified by a simple integer. And we'll use that later on because we have to ferry that identifier back to what we know as the task ID, UUID, and how do we connect the two. That's the fun part on the Globus compute side. So I mentioned this briefly a second ago. The next step is actually emitting the events. So the events that we get from Parcel are the manager's first registered, but it doesn't have any tasks yet. So okay, holding on to it, we keep record of that manager, of that node manager, but nothing happens, nothing of interest. And it's similar, we have a task that is emitted, although we rarely see it, I think, in our realm here, when it manages to decommissioned. But again, boring, no tasks are associated with that manager because it's going down. The fun part is when a manager gets new tasks. And so Parcel does emit an event after assigning a set of tasks to a node manager. It also emits a node info message when results are received, and normally the tasks have been removed from the node, but we don't really care about that per se. It's not pertinent for this talk. So far, so good? I'm kind of talking fast here. Okay. That's what we care about on a compute level, or on the Parcel level. So now we get to move into compute, which is a little dirtier. Before starting this, we had to do a couple of things. The first thing was to make a data structure to hold some of this meta information. We're looking at the block ID, the job ID, the task ID, all combined into one, which was a mind shift, I think, because we had done a set fire and forget method from within the endpoint previously. This was the results pass through queue and the results pass through thread handling. But as soon as we implemented this, you may remember reviewing the PR, realized there's no need for either of those anymore. We have the GC future, which holds the relevant meta information for each task. And thanks to Python's future guarantees of ferrying along results when we set result in the future, we can simply do an event-based. When a result is ready, we can let it know, send it upstream. We no longer need the result pass through. We no longer need the thread. It can go away. Fantastic. That was a nice side effect of this work here. But the GC future was the internal data structure was the key structure first. And then this is the part that blew my mind, in retrospect, that the future we hold on to, which is roughly analogous to the upstream SDK task, is not the future that Parcel has or the executor has, because that is a submission-specific event within Parcel. And specifically, what happens when we want to resubmit a task, retry a task. Parcel views that as a new task, even if it's the same fundamental task that we care about, and we get a new executor task ID. So the bookkeeping is in holding on to our notion of the task and the executor task ID that changes potentially, and the job ID and block ID that changes with that task being resubmitted. So for a mental model, which may or may not help, the GC future is roughly what we receive from upstream, and we hold on to it until the task result is sent back upstream. Meanwhile, the executor future is the parcel resubmission as many times as one. So 1 to n versus 1 to 1. The whole thing, though, about the GC executor future is that executor task ID attribute, and I'll show that bookkeeping a little bit later. So far, so good? Okay. I'll assume if you have questions, you'll speak up. And if you're speaking, I'll do a good. Oh, go ahead.
You're speaking. Go.
Oh, Kevin, what happens if there's a failure? Like, how is that tracked?
What kind of failure?
If, say, a manager lost and the parcel future basically just dies, it just fails.
That is tracked in the retry logic in that PR. So when we try 0 or more times, we hold on to that exception and attach it to the
Oh, that's what yeah. So what happens to the executor task ID? Do we change that? That's what I'm trying to figure out.
Yes. If we resubmit, yes.
Okay.
That's some of the bookkeeping that happens.
Right. I'm just trying to understand, like, does it make sense to, I understand that keeping the executor task ID point at the single the actual task ID makes sense. Do we ever keep history?
Let's be clear. What actual task ID? They're all actual task IDs. It's relevant to which part of the abstraction layer.
Right. The parcel task ID. Do we keep a history of those?
Because it has multiple task IDs with a retry.
It's a multiple one-to-many mapping, right?
We do in the audit log, yes. I don't think we hold on to that per se in the messages that go back, for example, the exceptions.
Is any of this information made accessible to the user, or is it all for logs?
This is all for the audit logs right now. We could make it accessible somehow. I haven't thought that through, and you could certainly parse through the parcel logs.
Yeah, maybe a user doesn't want to know this. I was thinking about particularly the batch job mapping, but maybe by definition we want to keep that hidden.
Right. I'm just thinking about the situation. Like, if the job dies and the task dies as a consequence, and we retry and get better, it's fine. Like, the user may not care so much about that. But if it's a situation where the task fails because it runs out of memory, it's going to fail multiple times and then fail out. Maybe the fact that it failed out multiple times and keeping history of that and what workers it killed may be useful.
Yeah. And admin certainly will want to keep track of all of this, I think, in the logs. So, yeah.
Okay, cool. Please go on. So,
okay. Let's see. So the key detail there is the executor task ID. So part of that precursor work still was to hook into that new executor task ID attribute and to teach all the engines this generic executor task ID concept. So in parcel land, I'll show it in the next slide here, parcel calls that executor task ID parcel executor task ID. But in our sense, I want to translate that to a generic executor task ID. And in code, that looks like, with redactions, basically, you see the counter, the integer, which becomes the ID, monotonically increasing, and then attached willy-nilly to this plain Jane concurrent futures future object, which we then turn around and call a GC executed future, because we care about is the next aspect, which is the executor task ID. And then we do a similar dance for the process pool engine and the thread pool engine of setting the executor task ID so that the rest of the infrastructure can rely on the executor task ID. That's the key detail here of what does the executor call this set of work. And then once that's in place, we tie it to the task feature. And these two, this right here is the mental separation, if you will. The work F is that raw future we got from parcel, which we then cast as a GC executed future, so we can have access through MyPy not complaining to us about the executor task ID, and then we set that executor task ID on the task future for later bookkeeping. Okay. Now it's time to move on. Overrided, yes, that's the detail here. That one reason for this is precisely because you can be re-invoked multiple times for the task retries. So I want to make sure we hold on to that. That's a big detail. That took a while to get right too. So now back to that black magic. We have set this queue. It's now time to consume it. So having removed the thread of the result pass-through handling, we create a new thread to handle monitoring. So that's a wash. This one blocks on getting, and I'm throwing out for this slide some details here, but the core of it is what I have here of blocking on getting a node info message, and then processing that node info message. And we also take advantage of parcel already doing some of the bookkeeping for us, the block to job ID, which is important, so we can share that. And then we set the task placement, and that task placement is a boring function. It's simply a for loop setting the block ID and the job ID on each task future we look up in our data structure. So I'm going to ignore that for now and say trust me, and you'll go look at the code if you want to. But what is cool is what happens when we do that, and that's the observer pattern I mentioned in the title there. So while set task placement is boring, we do implement on the GC future an observer pattern via .bind. And that looks something like this. So when the task feature is sent in to the executor, to the engine, first thing the engine does is bind it. When that attribute changes, not is set, changes, call that function. Whatever the execute, in this case, it's updating the internal mapping for the Globus compute engine base. But it's a series of as many callbacks as you want. All right. And that is the infrastructure in place. Finally, you have on the interchange side of things, when you create the GC future, set up your observers, and those functions there, I'm ignoring the what they call self.audit, and they say either executor start or running. And then finally, we have a final audit for when it goes back upstream to we're done, executor done. But that's it in a nutshell. A lot of minutia bookkeeping. I tried to keep it at a high level to understandable, but not complicated other than the simple details get complicated fast.